All right, chiral. What do we have to have for something to be chiral?
Mirror images. Yeah, so I think
The stereo center? And the enantiomer is so whichever compound you're looking at that's got a chiral carbon in it, it's going to have a mirror image of itself. Every time there's one stereo center, one chiral carbon, that gives you a mirror image. So if you've got a molecule and it's got two chiral carbons in it, how many different possibilities are there for that molecule? 4. You could have a plus plus, a plus minus, a minus plus, and a minus minus. And those are, or you could say R, S, L, R. So each of those are different possibilities. Two is the number of possibilities for the chiral carbon. It's either this or it's mirror image. And then you raise it to the power of the number of chiral carbons. So if I'm looking at a molecule and it's got 2 chiral carbons in it, the answer is 4. If it's got 3 chiral carbons in it, the answer is 8. 2 times 2 times 2.
Were you waiting for it?
I was, and I was listening to the 9 that was coming over here.
I'm super confused right now.
About what?
What are you talking?
We're talking about the carbon atom that's got different things on it and how it's got a mirror image. And so that's only got 2 options.
Where did stereo center come from?
Stereo center is a chiral carbon.
Then what's stereoisomer? Same thing?
A stereoisomer is, I've got that substance there that I drew, and it's stereoisomer, which is also its enantiomer. You like English language, right? No?
No, it's a different language, but
And the power is the number of chirals.
The power is the number of chiral carbons. So something that's got 3 chiral carbons on it, it would be 2 to the 3rd, which would give you 8 different possibilities. It's the same way it's the same kind of math you use to figure out how many different lysine plates there are. So what are the requirements for a compound to be considered chiral? So the chiral carbon makes the entire molecule chiral. It's not just like that carbon is chiral. Because there's a chiral carbon in it, now the whole molecule is considered chiral. That whole molecule has a mirror image of itself, or more than one, depending on how many there are. So draw a couple enantiomers. How about a carbon that's got a methyl group, an ethyl group, a fluorine, and a hydrogen. So that carbon that's in the center there, it isn't attached to 4 different atoms, right? What atoms is that carbon attached to? A hydrogen, a fluorine, a carbon, and a carbon. So because it's connected to 2 carbons, does that mean it's not chiral?
depends on what those carbons
Depends on what those are connected to. So you can't just look at the first thing it's connected to. You have to take it all the way out to the very end. And if everything matches exactly to the very end of something else that's there, then it's not chiral. So if this, instead of being a CH3, was a CH2, CH3, is this chiral? Nope, because two things are exactly the same. But what if it's a CH2, CH2, Br? Now it's chiral. But let's go back to our molecule, so a methyl group up here. So the easiest way to draw it is just leave the top and the bottom as is, and then flip-flop the centerpieces. So now they're mirror images of each other. Are you okay with that? Okay, so what's this first molecule's name? Propylbenzene? Okay, I'm good with that. Is there another name it could be? That's all we got. Just those two, or those are the only two possibilities. So in our first, we named it for benzene, right? And then the second one, we named it for the propane and treated the benzene as a side chain. So in the second one, where did the iso part go for the second name? No, where did it go on the second name? There's no iso on the second name. Why not?
The phenyl group is connected to the second.
I'm treating, when I'm saying iso, I'm treating that thing as a side chain. The second name here is treating the propane as the main chain, and then there's something connected to it, and that is a phenyl group. Okay.
Could you say sec, phenyl propane, or is there a sec?
There's no sec.
There's no sec?
There's no sec because there's only two possibilities for the propane. It's either connected on one of the ends, which is just propyl, or it's connected to the middle one, and that's iso. They could have used sec, but
Okay.
they chose
That
iso.
may be a couple-
Sure, for sure. We're going to see sec in a second.
that should-
So how many carbons do we have here? 4? Okay, so this is either butyl, benzene, or what is it? Are you okay with that? Butane, 4 carbons in a row, and what's attached to the butane? On carbon number 1, there's a benzene ring, so then we treat it as the phenyl side chain.
But if that's carbon number 1, then it'd be a pentane?
1, 2, 3, 4. No, Why do you think that?
1, 2, 3, 4, 5.
1, 2, 3, 4.
Oh, yeah, because that carbon is part of it.
Yeah, that is confusing.
Sometimes I,
So you've got a ring structure, right? These carbons here are in the ring. Can't be counted in any chain.
On the second one, can you call that a,
Nope,
Not at all.
not at all.
And a propane, no, because the carbon.
It's not a toluene. No place on that molecule is there a methyl group.
So you can, okay,
So you want to say that this is a toluene?
I have at 1 and 2.
Yeah, let's not do that because
But-
it doesn't
but
exist.
But it would have to share a carbon, so. yeah.
Um,
Because there's a carbon at, if that was, then there's a carbon at the end, and it can't be the same carbon in the,
Don't care about that. That's not the important part. The important part is a toluene is a benzene ring with a methyl group on it. Is there a benzene ring with a methyl group? What's there?
just the benzene.
And what? 3 carbons, right? Not 1 carbon, 3 carbons. You don't get to say that I've got 4 carbons in a row, but I'm going to count this as something else, and then these guys, it's not. That's the chain. The chain is 3.
Is there a way to add onto the end of?
You want to put like
Yeah, I mean,
a bromine right there and name
No,
it?
I mean, if that benzene actually had a methyl group,
Here?
how would the propane look attached to it? Would it have to be on the benzene ring? It can't be on the,
It can't be on the methane. It's not methane anymore, right?
Okay.
So methane means how many carbons?
I mean, one, excuse me.
Okay. So what happens if I attach a carbon to the methyl group?
Well, it'll get longer, I get that.
Then it's not methane anymore.
Right.
So you can't attach anything to this. So right now, as drawn, that little thing that I've got drawn is what?
Is
Is toluene. If I do anything to this carbon right here, what happens?
then it won't be.
Then it's not toluene. Because toluene is incredibly specific as a benzene ring with a single carbon coming off of it.
So does a phenyl group, does that have to be a benzene ring?
Has to be a
Double
benzene ring.
bonds can't be like all single bonds.
It's not alternating double bonds
For both, yeah.
that delocalize pi. It has to be a benzene ring. It can't be a cyclohexane.
Yeah.
It cannot. If it's a cyclohexane, it gets completely renamed because the reactivity of it is completely different. Okay, so what's this one? So you can call this sec butyl benzene, or you can call it what? Right? All I've done is I've moved the phenyl group from carbon number 1 to carbon number 2 on my 4 carbon chain. How about this next one? What is this thing? That's 4 carbons in a T shape, so it's tert butyl. So this is either T butyl benzene. That's the quickest way to write this, but I can write it another way. So I could say that this right here is a propane chain. So there's a propane. What is attached to my propane? A methyl group on number 2 and a phenyl group on number 2. Okay, so 2 phenyl, 2 methyl propane. So both of those are acceptable. Almost everybody would name it the first way just because it's shorter. And then this last one?
Sex-butyl benzene.
Yeah, it's, these two right here are the same, right? Drawn differently, still connected the same way. So this is also a sec-butyl benzene or a 2-phenyl benzene. All right, so what's up with this line drawing? What is this demonstrating? That circle is representing the 6 electrons that are all p electrons that are delocalized. So what this looks like is I've got my 6 carbons, and then I've got above and below the little donut-y shape where the 6 electrons are allowed to travel around in that circle above and below. And that benzene ring is a flat structure. So this guy, 1, 2, 3, 4, 5. So it's either pentyl benzene, or it's 1-phenyl pentane. We okay with that? What about the next one? Sure. We're okay with M-ethyltoluene, 3-ethyltoluene, meta-ethyltoluene. Are there any other names? I'm just gonna say it's got I got a benzene ring, and I also have a methyl group and an ethyl group attached to it. Positions 1 and 3. Okay, how about the next one? That's a phenol.
Fluoride.
2-fluorophenol, or ortho, or O-fluorophenol. Any of those will work.
When you say 1-fluoro, 2-hydroxyl.
Absolutely. 1-fluoryl 2-hydroxyl benzene would also work, for sure. How about this last one? Sure. Para, opposite side, nitro, and NO2 group, and then that's benzoic acid. Show the structural diagram labeling primary, secondary, tertiary, and quaternary. Okay. I feel like we've done this before, but. I believe this is the smallest molecule that will do all of that. So this one on the end is a primary, this one on the end is a primary, this one on the end is a primary, and this one's the end is a primary. Nope, I don't have enough here. Sorry. Let me put another one here. And then I'll do one right there. There we go. Let's go back to that. So a primary. And this one here is secondary because it's attached to 2 carbons. And then this one here is a tertiary because it's attached to 3. This one's a primary. And then this one here is a quaternary. You good with that? Why is the knowing if it's primary, secondary, tertiary, quaternary important? Yeah, it's about how fast that particular carbon is going to react, or if that particular carbon is going to react at all. This is the reason why drinking isopropyl alcohol will kill you, and drinking regular alcohol won't kill you right away. Or you can consume a lot more. Do you guys know who the Food Babe is? The Food Babe? Good. If you ever see anything about it, just flip the page, turn the channel, just don't ever listen to her. She just wants to make money off you. That's it.
Tell us why other than that. Or
Um,
else I'm gonna go Google it and I'll have to read it.
And be like, I should buy some.
She's telling people not to eat things because there are toxins. She uses the word toxin every time she can't pronounce something. She has actually said, if a 3rd grader can't pronounce it, then you shouldn't eat it. as a chemist, I would say, if I'm basing my nutrition off the competency of an 8-year-old, I should probably have some other basis for science nutrition. You'll probably have type 2 diabetes, yeah, because third graders can say sugar all day long. She is actually on record saying you should never allow a chemical to go into your mouth. Yeah.
It doesn't brush your teeth then.
She doesn't drink water. She doesn't eat food. She doesn't do, nothing goes into her mouth, right?
So she would.
Yeah. All right, write the full structural comp for hydrobromic acid and 2-butene. So I'll just draw this out. So 2-butene would be there. And so then I got a hydrogen. I did a poor job naming this structure, didn't I? What's wrong with 2-butene? It's not going to matter for this chemical reaction, but what's wrong with that name? Why didn't one of you message me and tell me I wrote down a stupid name?
Isobutene?
ISO?
I guess I can't do that.
It's not ISO. Wow, this whole thing is bad. Just bad, bad, bad.
Of where the bonds want to form.
No. It's either cis or trans. This one is drawn as cis, correct? But if I would have drawn this up here, then what is it? Trans. So that 2-butene needs a cis or trans name. It won't matter for this chemical reaction, but this chemical reaction is completely stupid anyway. Does anybody know why this is just a bad reaction? Was I doing this on purpose? It's a bad reaction because I was trying to prove a point, and I don't prove any point because this is the only
It's the
possible
only one,
product.
I
Yeah,
was gonna try and say that you could get a different one, then I was like.
it is not
wait.
possible to get a different one here. Yeah. Are we okay with saying this is the only product? So this is an addition reaction. An addition reaction happens how? What do you need for an addition reaction? You need a double bond or a triple bond. That double or triple bond breaks, and I take two things and add it across it. So I took my H and my Br and I added across the double bond that broke, and I put an H on one side and a Br on one side. So what if they were flip-flopped? What would I get? The same thing, because it's only 2 carbons long. So that's why this was a bad example of a Markovnikov addition, because there's no chance of having a Markovnikov addition because there's only one possible product.
You didn't call it a Markovnikov.
I didn't, but if I would have put something else here, like a CH3 group, then you would have been forced to say that the bromine would have been here 98% of the time. And you would have gotten a different product because you would have been able to add the Br to one side or the Br to the other, but the Markovnikov says that the carbon that's got more carbons around it can better withstand that positive charge for a short period of time, more stable. So that hydrogen goes to the other side, and then the bromine goes to the side that has more carbons attached to it, which is why we did this problem right before we did this problem. But sadly,
That didn't translate.
that did not translate because this should have been something else. So, all right, we'll see that again later.